Hello and what's up? Let me walk you through our new equations. Don't freak out. They're pretty easy and they're all about energy, work, and power. So there's a couple of them, right? So let's start with work, right? Work. Work is when I apply a force over a displacement and it moves something. It moves something, right? If I apply a force on this and it moves it, I have done work. I've done work to it, right? I have to do work to things to move them. So work is real easy. It's W is work, and that equals force times displacement, F times D. All you have to do is multiply force times displacement, and you get work. And this is in joules, right? Joules. Joules, that's the unit named after a French guy. Joule, right? So work is force times displacement. Then we have our energies, right? So we have kinetic energy, the energy of motion when things move. So that's KE, kinetic energy, KE. And that is equal to 1/2 times mass times velocity squared, right? mv squared, 1/2 mv squared. And it's just like that, 1/2 mass times velocity squared. Pretty simple. Pretty straightforward, right? All right, so we have potential energy, right? We have potential energy, and this is going to be the energy that something has stored up if I raise it up high, right? So if I do work on something and I'm moving it over a distance, I have given my work and changed this energy. I've given it some kinetic energy, and I've changed it to potential energy, right? So it's up high now. That's a potential energy, right? This kinetic became gravitational potential energy. Now it has the potential to move, to turn back into kinetic if I drop it, right? So how much does it have? Well, my potential energy is mass, the object's mass, times its gravity, times its height, right? mgh. What is gravity? 9.8. We know that. We've been knowing that. So I've got my kinetic energy, my potential energy, right? And notice these two right here, if you add them together, if you add these together, it equals mechanical energy. Mechanical energy. That's the combined total of something's potential and kinetic energy, right? It's like two sides of the same coin. Like a skier at the top of a hill has a lot of potential energy, but as soon as it starts going down the hill, it gets speed, right? Velocity. Its potential is becoming kinetic. So its potential is going down, but its kinetic is going up. Those two together are going to always add up to the same thing though, right? Because energy cannot be created nor can be destroyed. It can only be transferred to these different types between kinetic and potential. When we look at the combined total of them, how much kinetic, how much potential, that's called its total mechanical energy, right? And all you have to do is just think about how much kinetic there is, how much potential there is. It's always going to add up to the same thing, like 100, right? Like 70, 30, 100, 30, 70, 100, 50, 50, 100, 75, 25, 100. It's always going to add up to the same thing. You get me? All right, so we've got our work, we've got our kinetic energy and our potential energy, and power is another one, right? Power is an interesting one, right? And also, I'm sorry, my energies are measured in joules, just like work. So these are measured in joules as well. How many joules of energy, how many joules of work, right? And power is a little bit different. Power is how much work happens per unit time, right? It's just work divided by time, right? And this, you probably have heard its unit. It's in watts, right? Just like your light bulb, that's what it's doing, right? There's work going on by the light bulb, and it's per unit time. So your house uses a certain amount of kilowatt hours, right? So that's a measurement of power, right? And it's work divided by time. That's how much power, right? The more powerful things do a lot of work in a little bit of time. And that's a power rating, right? So that's measured in watts. Now, the surprise that I would have for you and that I want you to see here is that we have work, kinetic, our energies, right? Kinetic and potential energies adding up to mechanical energy, and power. All these are in joules, but this one is in watts. Why do you think work and energy are both measured in joules? And that's Because they're the same thing, right? Work and energy are the same thing. It's just two ways to talk about the same thing. If I do work on something, apply a force over a distance, it moves something. It gives it kinetic energy, right? And if I move something up high, it gives it potential energy, right? So work and energy are the same thing. That's called the work energy theorem. So we can actually rewrite this and say that work is equal to the change in kinetic energy. Work is kinetic energy. It's the same thing. So if I wanted to know how much work is done on something, I can find out how much kinetic energy has changed, right? Because if I move something, right, if I apply a force and it moves something, it's got that kinetic energy. Now, where did it come from? From my work, right? From the work that I put into it. So this is what we're doing this week. You must know it. It's super important. So follow along with me below. I've got a PowerPoint. I do a whole presentation on it. Check that out and get my quick check done as soon as you can. Thanks, guys.